right, everybody, let's do section 2, water on Earth. In a galaxy called the Milky Way, 9 planets orbit a star known simply as the Sun. Some of the planets have spectacular rings, others have volcanoes that are larger than continents or storms that last for centuries, but only one of the planets, Earth, has a surface covered mainly by water. In fact, oceans cover about 70% of our planet's surface. That's why Earth is often called the blue planet. Earth differs from other planets in another important way. It is the only place known thus far where you, your classmates, your pets, your plants, and every other living thing can survive. The wide variety of life on Earth could not exist without water. All living things need water. Here's a riddle for you. What do you and an apple have in common? You both consist mostly of water. Water is a large part of every living thing. Water makes up nearly 2/3 of your body's mass. That water is necessary to keep your body functioning. All living things need water in order to carry out their body processes. In addition, many living things use water for shelter. Body processes. All organisms need water to carry out their body processes. Water allows organisms to obtain chemicals from their surroundings, break down food, grow, reproduce, and move substances within their bodies. Humans and other animals drink water or obtain it indirectly by eating foods that contain water. Many animals can live several weeks without food, but they cannot survive more than a few days without water. Plants and other organisms that make their own food also need water in order to carry out their food-making processes. Photosynthesis is the process by which plants use water along with carbon dioxide and energy from the sun to make their own food. Animals and other organisms depend on the food made by plants during photosynthesis. Animals may eat the plants or eat organisms that eat the plants. Shelter. Bodies of water provide habitats for many living things. An organism's habitat is the place where it lives and obtains all the things it needs to survive. You are probably familiar with large water-dwelling organisms such as sharks, but most water-dwelling organisms are microscopic, such as amphibia. In fact, aquatic or water habitats contain more organisms than land habitats. Distribution of Earth's waters. Look at Figure 8. It shows how water is distributed among saltwater and freshwater sources. On Earth, most of Earth's water, roughly 90%, is saltwater. Found in oceans, only 3% is freshwater. Of that 3%, about 3/4 is frozen in huge masses of ice near the North and South poles. Almost a quarter of freshwater is underground. A tiny fraction of Earth's freshwater occurs in lakes and rivers. An even tinier fraction is found in the atmosphere. Most of it is in the form of invisible water vapor, the gaseous form of water. Oceans. To explore Earth's waters, take an imaginary boat trip around the world. Starting in Florida, you head southeast across the Atlantic Ocean toward Africa. Swinging around the continent's southern tip, you enter the smaller but deeper Indian Ocean. Next, you travel east across the Pacific Ocean. This vast ocean covers an area greater than all the land on Earth combined. Pacific, Atlantic, Indian. These are the names used for the different parts of the ocean, but the waters are really all interconnected, making up one big ocean. Okay? So where's most of the freshwater located? In the glaciers. Okay? So here's our distribution of water. So this is the part that we can actually use. 76% is in ice, 12% is shallow underground, 11% is deep underwater, 0.34% is in lakes and rivers, and 0.037% is water vapor. Ice. How can you get back to Florida? You can sail all the way around South America, but watch out for icebergs. These floating chunks of ice are made of fresh water. Icebergs in the southern Pacific and southern Atlantic Oceans have broken from massive sheets of ice that cover most of Antarctica. If you travel around the North Pole, you would also find icebergs in the Arctic Ocean and in the North Atlantic. rivers and lakes. To see fresh waters in rivers and lakes, you'll have to make a side trip inland. Sail north past Nova Scotia, Canada, to the beginning of St. Lawrence Seaway. Navigate through the series of locks along the St. Lawrence River. Suddenly the river widens and you enter Lake Ontario, one of North America's 5 Great Lakes. The Great Lakes contain nearly 20% of all the water in the world's freshwater lakes. Groundwater. Some of the fresh water on Earth can't be seen from a sailboat. To find it, you would have to go underground. When it rains or snows, some water soaks into the ground. This water trickles down through spaces between particles of soil and rock. Eventually, the water reaches a layer of rock that it cannot move through. Water that fills the cracks and spaces in underground soil and rocks is called groundwater. Far more fresh water is located underground than in all of Earth's rivers and lakes. You'll learn more about this in the groundwater in section 5. All right, the water cycle. So the water cycle moves continuously through the cycle from Earth's surface to the atmosphere and back. The sun's energy drives this process. So the sun causes water to evaporate from the plants, the lakes, the oceans. It goes into the sky. When it gets high enough, it goes through condensation and forms rain or snow or hail, and that is precipitation. And then it goes and it runs down into the lakes again and the oceans, and it can go into groundwater, and again that cycle begins again. Earth's water is naturally recycled through the water cycle. The water cycle is a continuous process by which water moves from Earth's surface to the atmosphere and back. In the water cycle, water moves from bodies of water, land, and living things on Earth's surface to the atmosphere and back to Earth's surface. As shown in Figure 9, the water cycle has 3 major steps: evaporation, condensation, and precipitation. The cycle itself has no real beginning or end, but is driven by the energy source, the sun. Water evaporates. As you learned earlier, evaporation is the process by which molecules at the surface of a liquid absorb enough energy to change to a gaseous state. Water is constantly evaporating from the surface of oceans and large lakes, smaller amounts of evaporation from the soil, puddles, and even from your skin. Plants play a role too. In this step of the water cycle, plants draw in water from the soil through their roots. Eventually, the water is given off through the leaves as water vapor, and this process is called transpiration. Condensation forms clouds. What happens after water molecules evaporate? Warm air carries the water molecules upward. At higher altitudes, air tends to become colder. Cold air cannot hold as much water vapor as warm air can. As a result, some of the water vapor cools and condenses into liquid water. Condensed droplets of water clump together around tiny dust particles in the air, forming clouds. Water falls as precipitation. As more water vapor condenses, the water droplets in the cloud grow larger and larger. Eventually, they become so heavy that they fall back to Earth. Water that falls to Earth as rain, snow, hail, or sleet is called precipitation. Most precipitation falls directly into the ocean. The precipitation that falls on land may evaporate immediately or run off the surface into lakes and rivers. From there, it may evaporate or flow back into the ocean. In addition, some water may trickle down into the ground. After a long time, this groundwater may reach a river, lake, or ocean and continue the cycle by evaporating again. Precipitation is the source of all fresh water on and below Earth's surface. The water cycle renews the unusable supply of fresh water on Earth. For millions of years, the total amount of water on Earth has remained fairly constant. Rates of evaporation and precipitation are balanced. All right, today's homework is Section 2 assessment. I will see you all tomorrow. Bye.